In this video, we're going to talk about arithmetic series. Let's start with a story. It's the story of little Gauss. Little Gauss was about 10 years old and he was causing problems in math class one day. So his teacher decided to give him some work to keep him busy so that he would stop disturbing the other students. The teacher asked little Gauss to add up all the numbers from 1 to 1,000. Much to the teacher's dismay, little Gauss returned with the correct answer of 500,500 after a couple of minutes. The teacher knew this to be the correct answer, but could not understand how Gauss got the answer so fast. So little Gauss explained. First, Gauss listed all the numbers from least to greatest. He didn't actually have to list them all, of course, using dots like we are going to do below. Then he listed all the numbers from greatest to least. Okay. So Gauss understood that if he added every number shown, including the ones hidden by the dots, then he'd have double the value he was asked to find. And Gauss understood that instead of adding them all horizontally and then adding the sums of the two rows, what he could do is add them vertically and vertically and vertically and add the sums of the 1,000 columns. So he understood that the first column equals, when you add those numbers, is 1,001, and so is the second column, and the third, etc., etc. They're all 1,001. And we can also see that there are 1,000 of those columns. So reading the last sentence there, therefore the sum of all the numbers in the two rows is 1,000 times 1,001. And as we said earlier, the sum of the two rows would equal 2 times the sum that Gauss was asked to find. So therefore, the sum that Gauss was asked to find was actually 1,000 times 1,001 divided by 2, which is 500,500. So another way to think of this is to say that the sum is 1,000 times 1 plus 1,000 all divided by 2. And if you consider the sum of all the terms to be Sn, then what you could do is say Sn is equal to n. So the sum of the first 1,000 would equal n, which is 1,000, times the first term plus the last term, which is 1 plus 1,000, divided by 2. Okay? And as we'll see later, this is one of the commonly used formulas for determining the sum of an arithmetic series, but there's another formula that's even more commonly used than that. So let's talk about what a series is. A series is the sum of the terms of a sequence. There are similarities between a sequence and a series. So for example, 7, 11, 15, 19, etc., that's a sequence. 7 plus 11 plus 15 plus 19 plus etc., that's a series. An arithmetic series is a series in which the same number is added to get from one term to the next for each term in the series. Now, the sequence 7 plus 11 plus 15 plus 19, etc. is an arithmetic series because each term, starting with the second term, is 4 greater than the previous term. As you can perhaps tell, the method for determining the value of a particular term of a series is the same as the formula for determining a particular term of a sequence. They're the same, the terms are the same. So what we're saying here is we can use this formula that we already learned in the arithmetic sequence section to determine a term of an arithmetic series. Okay, A is the first term in the series and D is the difference between consecutive terms. So if we used, looking at the one on the previous page, 7 plus 11 plus 15, etc., we could say A is 7 and D is 4. So if we wanted to evaluate T3, we could say T3 is A plus n minus 1, 3 minus 1, times D, which is 4, and the answer would be 15. But when we discuss series, we're also interested in knowing the sum of the terms. So for instance, in the above series, S3 will equal the sum of the first 3 terms. Specifically, S3 is simply 7 plus 11 plus 15. And that is 33. Now, if you only have to add 3 terms, because you only are looking for the sum of the first 3, it's pretty easy to do. Don't probably need a formula for that. But what if we wanted to add the first 2,000 terms? We would certainly like a formula. So we actually, fortunately, have one, a formula for determining the first n terms of a geometric series. And in fact, we have two of them. If the first term of an arithmetic series is a and the common difference between consecutive terms is d, then the sum of the first n terms can be evaluated by either formula. This one, which is inspired by Gauss, or this one, which isn't really the method that Gauss was using. It's obviously very much related to that, but it's another formula. And in fact, nothing against Gauss, but I usually focus on using the second one. The first one requires us to know the last term, whereas the second one doesn't. So I find that there are situations in which the second one is perhaps a little easier to use. So what if I told you the 80th term of the arithmetic series shown is 145, and then I ask you to determine the sum of the first 80 terms? Well, in the rare case when we know the value of n and also know the value of the nth term, we can use the formula that's inspired by little Gauss. We can say that Sn is n times t1 plus tn all over 2. In this case, n is 80 because we're looking for the sum of the first 80 terms. So n is 80. And we can say it's term 1 plus term 80 all over 2. Well, they were nice enough to tell us term 1 is negative 92 and term 80 is 145. So we just have to say it's negative 92 plus 145 quantity divided by 2 and then multiply that by 80. And the answer is 2,120. Now, what if we wanted to determine the sum of the first 815 terms of the arithmetic series shown? Right there. Well, we can use the other formula because that one doesn't require us to actually figure out what the 815th term is. Obviously, we could, it wouldn't take long. But we can use the second formula and perhaps get there just a little bit quicker. We see in this series the first term is 101. To get from the first term to the second term requires us to add 7. So we can simply use this formula and say the sum of the first 815 terms will be 815 over 2 times 101 plus 815 minus 1 times 7. Ultimately, doing Bedmas there, we get 2,404,250. What if we wanted to know the sum of the first 108 terms of the arithmetic series shown? Well, we could say, obviously, a is 7 over 5. We know that it's arithmetic, so we don't have to establish that it's arithmetic. We can find the common difference by just simply determining what 23 over 15 minus 7 over 5 is. And the answer is 2 over 15. So now the sum of the first 108 terms will be 108 over 2. And then in brackets, we'll have 2a, which is 2 times 7/5, plus n minus 1 times d, which is 108 minus 1 times 2/15. We're going to do a little bit of mathematics here, a little arithmetic involving common denominators at one point. And we're going to end up with the answer of 4,608 over 5. Now, what if we wanted to determine the sum of the arithmetic series shown? Okay, well, in this case, we see a is 183. D is actually negative 21, because to get from one term to the next, we subtract negative 21. But we need to know what n equals. So what we're going to do is we're going to let Tn equal negative 1,938, and then we're going to solve for n. All right, so we recall that the formula for Tn is a plus n minus 1 times d. So what that means is that the nth term is 183 plus n minus 1 times negative 21. Or in other words, the nth term of this series is negative 21n plus 204. Well, we're going to let the nth term be negative 1,938. So letting negative 1,938 equal negative 21n plus 204 ends up establishing that n is equal to 102. So in other words, what they're saying to us is determine the sum of the first 102 terms of that series. N is 102. So recognizing that n is 102 and a is 183 and d is negative 21, we end up with a sum of negative 89,505. Now, what if we know that an auditorium has 3,500 seats? We know the first row has 80 seats, and every row after that has 10 seats more than the prior row. We want to know how many seats there are, how many rows of seats there are. So it's an arithmetic series because we're always adding 10 to each term. Picture that auditorium. We have 80 seats, and then we have 90 seats, and then we have 100 seats, and then we have 110 seats. And we know ultimately that we get to 3,500 seats, but we're curious, how many rows does it take to get us there? Okay, so we know A is 80, and we know D is 10. And oddly enough, we actually know what Sn equals. Sn equals 3,500. But we don't know what n itself equals. So we're going to let 3,500 equal n over 2 times, and then in brackets, 2 times 80 plus n minus 1 times 10. So 3,500 equals n over 2 times 160 plus 10n minus 10. In other words, 3,500 equals n over 2 times 10n plus 150. Okay? Now, many of us learned in grade 9 a very convenient thing to do at this point is multiply both sides by 2. It'll get rid of that denominator. When we do that, we have 7,000 equals n times 10n plus 150. Distributing that n, we get 7,000 equals 10n squared plus 150n. We can subtract 7,000 from both sides, and we get 0 equals 10n squared plus 150n minus 7,000. Now, at that point, we have a quadratic, and we realize it's good to factor out the 10. 0 is equal to 10 times n plus 35 times n minus 20, meaning n plus 35 is 0 or n minus 20 is 0. So either n is negative 35 or n is 20. And then, of course, we go back and we say, what did n represent? N represented the number of the rows of seats. So it's not going to be negative 35 rows, so we can say that there are going to be 20 rows in that auditorium. Now, what if we know that the 30th term of an arithmetic series is 283, and we know that the sum of the first 47 terms of the same series is 10,763? We'd like to know what the 115th term of the series is. Okay, well, what we're going to do is we're going to say the 30th term is a plus 30 minus 1 times d. So the 30th term is 283. So 283 is a plus 30 minus 1 times d. And so that means 283 is a plus 2090. The 30th term will always be a plus 2090, and the 30th term is in fact 283. We can actually isolate a, and we'll get our first equation of a equals 283 minus 2090. Now, we also know that the sum of the first n terms equals n over 2 times 2a plus n minus 1 times d. Well, we know what n is. N is 47. So we plug 47 in there, and we still have these unknown values of a and d. We have specifically the sum of the first 47 terms equaling 47 over 2 times 2a plus 46d. Distributing 47 over 2 into the bracket, we get the sum of the first 47 terms equals 47a plus 1,081 times d. Now, we know that the sum of the first 47 terms is 10,763, so that means 10,763 equals 47a plus 1,081 times d. We're going to take that equation 1, where it said that a is 283 minus 29d, and we're going to sub it in. When we do that, we distribute in that 47, and we end up with this equation here. Big numbers, 10,763 equals 13,301 minus 1,363d plus 1,081d. We ultimately end up with d equaling 9, following some fairly straightforward math steps. We know d equals 9. Well, that's good. Well, we also know a is 283 minus 29d. So plugging in a d value of 9, we get a is 22. So now what we know is that we're talking about a series where a is 22 and d is 9. Well, once you know that, it's pretty easy to find out the nth term. Tn is a plus n minus 1 times d, meaning T115 is 22 plus 115 minus 1 times d, which is ultimately 1048.